This work presents a profound exploration into the hidden mechanisms of the universe, offering insights that transcend conventional understanding. The information contained within was illuminated through painstaking revelations and meticulous research over the course of 30 years by L.S. Larkey. The theories presented here, ranging from the redefinition of gravity to the stellar origins of celestial bodies, are protected under copyright law, having been revealed and published in the Unified Theory of U and the L.S. Larkey Theory of Gravity. These ideas do not simply challenge existing paradigms. They reveal a new cosmic narrative that reshapes our understanding of the universe and the forces that govern it. This is a journey into the unknown, bringing to light truths long hidden and emerging from decades of dedicated research. The contents within this work are not merely a collection of theories, they are the key to unlocking the universe's most profound mysteries. All materials within this work are copyrighted, and any reproduction, duplication, or use without the explicit permission of the author is strictly prohibited. As you read on, you will discover concepts that illuminate the very essence of existence, offering perspectives that transcend the boundaries of traditional thought, all rights reserved. The Moon, a White Dwarf, and the epic story of cosmic mitigation. For millennia, the Moon has been regarded as a rocky satellite of Earth, widely believed to have formed from the debris of a massive collision between Earth and a Mars-sized body. While this narrative has been accepted by much of the scientific community, it leaves certain crucial questions unanswered. What if the Moon is not merely a remnant of Earth's aftermath, but a white dwarf, the dense remnant of a once powerful star now orbiting our planet? Recent insights into the Moon's unique chemical composition and a deeper understanding of cosmic pressure reveal a far more complex story. This redefinition of the Moon's origin compels us to revisit our understanding of both the Moon and the broader nature of stars. The stellar origins of the Moon, chemical evidence from plasma fields. One of the most compelling pieces of evidence supporting the idea that the Moon was once a star lies in its chemical composition. Lunar samples collected during Apollo missions revealed the presence of elements like Helium-3, a rare isotope on Earth, yet relatively abundant on the Moon. Helium-3 is typically associated with plasma fields, suggesting a stellar origin for the Moon. In traditional astrophysics, stars are powered by nuclear fusion, where lighter elements combine to form heavier ones, releasing vast amounts of energy. However, in this theory, nuclear fusion is not responsible for generating the energy observed in stars. Instead, the plasma fields we observe from stars are created by the interaction between a celestial body's subtle magnetic field and the intense pressure exerted by the relative vacuum of space. Unlike mainstream scientific models, this theory posits that all stars, including the Moon in its former state, are hollow and do not rely on internal fusion processes for energy. Instead, the sheer size of these celestial bodies, combined with the strength of their subtle magnetic field, interacts with the relative vacuum of space to form plasma fields on their surface. These plasma fields account for the brilliance we observe in stars without the need for nuclear fusion. The Moon, having once been a massive star, retains traces of its plasma field elemental makeup, further supporting the idea of its stellar origin. Understanding the collapse of the magnetic field and the creation of a white dwarf. As the Moon's subtle magnetic field collapsed, it could no longer sustain the delicate balance that had once maintained its plasma field. The immense pressure from the relative vacuum of space, amplified by the Moon's colossal size, forced the creation of a plasma field on the Moon's surface in an event that we call supernovas, and in this theory is a death of a star. This surface interaction became so intense that the Moon eventually transitioned and was reduced into a white dwarf, the star remnant we observe today that we call our Moon. In this model, plasma fields are not created through internal processes. Instead, they are formed through the interaction between the surface of a colossal celestial body or a dynamic subtle magnetic field of a central star and the surrounding vacuum of space. As the pressure exerted on this dying, massive celestial object increases, a plasma field is generated, ultimately leading to the formation of a white dwarf. This understanding challenges traditional views of how stars operate and evolve, offering a new model of stellar collapse and transformation. The role of cosmic pressure in stellar evolution. The key to understanding how stars, including our moon, evolved into white dwarfs, lies in the interplay between the relative vacuum of space and the star's diminished subtle magnetic field. When a star is born, its magnetic field interacts with the vacuum, creating a plasma field that allows the star to emit light and energy. Over time, as the star's magnetic field weakens or collapses, it succumbs to the immense pressure of the surrounding vacuum. This pressure, rather than an internal force, drives the star's transformation into a white dwarf. In the case of the moon, the collapse of its subtle magnetic field led to a loss of equilibrium with the external pressure exerted by the relative vacuum of space. As the magnetic field weakened, the moon could no longer sustain itself against the immense external pressure. Without the stabilizing force of the magnetic field, the moon succumbed entirely to this pressure, leading to the creation of intense surface plasma fields. This dialectical interaction between the moon's weakened magnetic field and the vacuum of space drove the transition from a star to a white dwarf, a process that continues to reflect the balance of forces governing celestial bodies. The moon's hollow structure and unique chemical composition, including the presence of Helium-Three, provide strong evidence of this transformation. The moon's artificial relocation. One crucial aspect of this theory is that the moon did not originally belong to our solar system. It was once a star in a distant solar system, but after undergoing a supernova, a process triggered not by internal fusion but by the collapse of its subtle magnetic field and the intense pressure exerted by the vacuum of space, the remnants of this star were artificially relocated to Earth's orbit. This artificial relocation suggests a level of cosmic intervention or manipulation that challenges the prevailing view of the moon's formation through natural celestial collisions. This theory of artificial relocation also helps to explain some of the moon's more peculiar characteristics, such as its perfectly synchronized orbit. Refuting the impact hypothesis. The traditional impact hypothesis, which claims that the moon was formed from the debris of a massive collision between Earth and another celestial body, fails to account for the moon's unique plasma-related composition. If the moon had been formed through such a collision, it would share more similarities with Earth's crust and mantle. However, the presence of Helium-3 and other isotopes associated with plasma fields suggests that the moon is much older and has a more complex stellar history. Furthermore, the impact hypothesis is undermined by the existence of the asteroid belt. According to traditional gravitational theories, cosmic debris in space should coalesce into larger bodies like moons or planets over time. However, the asteroid belt, which has existed for billions of years, has not formed a planet, despite containing vast amounts of debris. This reveals a fundamental flaw in the idea that debris will naturally coalesce due to gravitational forces alone. If the traditional view of gravitational forces were at play, they would be sufficient to form planets from debris. The asteroid belt would have long since formed a planet or a larger rock formation. This lack of coalescence in the asteroid belt directly challenges the impact hypothesis and supports the idea that the moon's origin lies in its former life as a star. In the grand cosmic narrative, the galaxy itself plays a pivotal role in shaping celestial bodies. Before the universe existed, there was an absolute void, an expanse of pure potential. When God said, "Let there be light," this void was mitigated by the first cosmic event, giving rise to the relative vacuum of space 1, or RVS1, and forming the universe. This first mitigation allowed matter to form and laid the foundation for galaxies, and within galaxies, stars and planets were able to form. As the universe evolved, galaxies became the second mitigation, RVS2, further regulating and mitigating the immense pressure of the void and creating environments where celestial bodies could take shape. Within galaxies, solar systems experience what is hypothesized as the third mitigation of the relative vacuum of space, RVS3. Planets with subtle magnetic fields like Earth reduce the intensity of the vacuum within their sphere of influence. These magnetic fields act as a buffer, mitigating the pressure from the relative vacuum of space around the planet. On Earth, this magnetic field does more than shield the planet from cosmic radiation. It also plays a crucial role in regulating the gravitational phenomenon experienced here. According to this theory, gravity is not an attractive force, but a gravitational push. The Earth's magnetic field interacts with the relative vacuum of space, reducing its pressure, which results in this pushing force that we perceive as gravity. This interaction between the magnetic field and the vacuum creates the conditions that allow life to exist while moderating the gravitational pressure in the planet's sphere of influence. The Moon's transition into a white dwarf is a direct result of these cosmic pressures, and its current state is a testament to the complex interactions between its magnetic field and the surrounding vacuum of space. The Moon's current state, a white dwarf in Earth's orbit. Today, the Moon is not merely a lifeless rock orbiting Earth. It is a white dwarf, the relic of a once powerful star that succumbed to the intense forces of the universe. Its hollow structure and the plasma remnants on its surface explain its unique chemical composition, particularly the presence of Helium-3. The Moon's transformation from a star to a white dwarf was driven not by internal nuclear fusion, but by the pressures exerted by the relative vacuum of space. By understanding the Moon as a white dwarf, we gain new insights into the nature of stars, gravity, and the forces that shape celestial bodies. The Moon's transformation from a star to a white dwarf offers a glimpse into the powerful forces at work in the cosmos, and its current state is a testament to the intricate balance between pressure and magnetic fields in the universe. Conclusion: a stellar relic, illuminating the cosmos. The Moon is not just Earth's satellite, it is a stellar relic, a white dwarf that once burned brightly as a star in the distant past. Its chemical composition, particularly the presence of Helium-3, provides undeniable evidence of its stellar origins. The interaction between the Moon's magnetic field, its hollow structure, and the relative vacuum of space offers a new perspective on the Moon's past, present, and future. By rejecting the traditional impact hypothesis and embracing the idea of the Moon as a white dwarf, we unlock deeper mysteries of the universe. The Moon's epic journey from a star to a white dwarf challenges established beliefs and invites us to explore the profound forces that govern the cosmos. This reimagined perspective of the Moon sheds light on the power of cosmic mitigation, the balance of celestial forces, and the enduring legacy of stars as they transition into quieter states of existence. This theory, supported by the Moon's chemical evidence and the failure of traditional gravitational models, invites us to reconsider the nature of all celestial bodies. In the Moon's journey, we find not only the remnants of a star, but the very forces that shape the universe itself. For those interested in exploring more about Larkey's theory of gravity, you can delve deeper into this groundbreaking concept by reading The Unified Theory of You. This book offers a comprehensive examination of cosmic forces, the nature of stars, and the interactions between magnetic fields and the relative vacuum of space. It challenges traditional scientific models and provides an enlightening perspective on the universe's hidden mechanics. The Unified Theory of You is available for purchase on Amazon, where readers can immerse themselves in these revolutionary ideas.